We are going to see now this example that you see. Using this example you see on the screen, how do you actually go from a system bone graph model to a block diagram. But first, I will illustrate how we actually make the bone graph model of the system. We will do the bone graph model without any reductions or simplifications, but lay out all the elements first and then do the block diagram. So let's see how we do this. We will go in here, and the first thing is we're going to do is we're going to write some steps in here. I like steps, so we're going to say steps. Step number one is going to be to recognize what elements we have. Okay, so in that regards, I will go and write some elements in here that we have, by using, we need to use a different coloring here to draw this. Let's just go here and say, let's hold on for a second. Let's just go full page view. That makes it a little easier to handle the menus. And in here we're gonna use the, I know this is red, so in here we'll go and do and say, okay, this is a external source, which we're gonna call it source of effort. This mass in here is going to be, obviously would be an I element in here, so this would be the I element. This one in here will be a C element, and this one on this side is going to be a resistive element. But in here on the wall side, we're gonna say this is a source of flow with velocity equals to 0. Yeah, very good. So we have actually done the first step. Then the second step is, I am going to say, is use, let's see, number 2. Use a one junction to represent the distinct velocities. Okay. Just so that it'll be all in this, all aligned. Let's see. Then number 3, well, let's do number 2 first. So in here we're gonna go and we're gonna write a one junction then for the velocity of the wall, which is 0. This is a reference point. Then we have a one junction for the velocity of the mass, which we call it x dot right here. That is step number 2. So the reference also, we put it as a as an element, so that we can actually draw the bond graph with respect to it. Then we have 3 would be step number 3. You're gonna say attach the elements that experience those velocities. Yeah. Okay. And then what you should do is you say, okay, look, in here we have this element in the source element in here. We'll say, okay, this is fine. This is going to be your source of effort with value F in here. We also have the mass, with this inertia element with value M. This is going to be our source of flow with value velocity of the wall equals to 0. That's what that fulfills step number 3. Step number 4, you're gonna say C4, gonna say use a zero junction to represent the velocity differences. And then I'm gonna put step number 6. I'm gonna say attach the elements that experience those velocity differences. Very good. So, and here we go. And we say, okay. This is the 0 here. And then you will do the velocity difference like this. And you create a velocity that's x dot minus velocity of the wall. That's what the that's what these two elements see, is those velocity differences. So in here we will put the two elements that see the difference, see, which with value 1 over k in here, and the other one, which is the resistive element with value b. Now, what I would say is that this element in here, this bond graph model is ready to be put into the CAMG software. And the reason I say that is because the CAMG software will actually assign the causal marks that are missing from this graph. You could say as a step number 3, you would say, I would just put number 7 and say, you say enter it in CAMG and verify the causality assignment. Those are the causal marks in here. I'm deliberately not putting them in right now, but I am going to go ahead and run the CAMG software, and then enter it into see, there's the bond graph that I have. I leave enough space for drawing it on the right hand side, and I come in here and I need to draw this let's see. Okay. I think I need to make the window on this too a little smaller and be able to have it side by side. Let me see if we can do that. Okay. Anybody knows where the mouse is? Oh, there's the mouse. Okay, here we go. We're, we're having an issue here with the okay. Let's try to bring the program again. Mm, yeah, right there. So bring it over here, and yeah, there we go. So we go over here and we say new. Okay. And now we proceed to draw this bone graft model on the screen. So this is going to be this SC over here, and then we put it in the one like this, and then we have I here, which is from here to here. Then we have the 0, which is from here to here. Then we have the 1, which is from here to here. Then we have the C element, which is from here to here. And then we have the R element, which is from here to here. And then we have this one junction right here. It goes from here to here. And then we have the SF here. And then finally complete the bone graft model like this. So what you have on the left hand side is what I have on the right hand side also. I am going to use the ability to get the, get a hold of the copying the right hand side. Fortunately, we need to have it like this to be able to do it. And so I am going to go here. There you go. And then I could just come back in here and paste this. And now let's look at the full screen in here and put it on the side, next to the steps in here. Yeah, just to make sure that our graph is correct. Let's just erase this. So this is the bone graph model as we have it right now. So from this bone graph, now I want to create the block diagram. So how are we going to do this? So let's first of all put the title in here. This is your bone graph. And now we would like to do the block diagram from this graph. So to do that, to generate the block diagram, I'm going to say steps for block diagram. The first thing is I would do is to create the let's see, step number 1 would be layout. You could say layout the bone structure and what do I mean? This would be the efforts and flows of each connection. Okay. So what I would do is I am looking at this bone graph in here, and I say, okay, look, I need to draw the connections for this. I am gonna do it this one, and for the other one here, the other connection is gonna be here. This connection that I'm talking about, this is E sub 8, right? Well, first of all, let me write down the layout the system first, and then we will do that. And then we have this. Then you have on the other side, you have this connection, and in here you have the I element in here, the connection for the I element in here, like this. Let's see, this connection you have for the this is the 1, the 0 here, the connection is like this, and then you have the other two connection like this, see, for the C element, and this one for the R element. Yeah, see, you see how I laid out. This is going to be like one of those things you see on TV. Just do lines first, then do other lines, and all of a sudden comes a very nice picture. Yeah? So what I would do is we need to start perhaps with the easiest elements, which are the sources on both sides because they are constants. One is 0 and the other one is just the value of f. So this is the value of f in here. You know, I think we need to do another write up on the steps. This is the steps I was saying, layout for each connection. And then you'll go to step number 2, which is I am going to move it to the right so that we don't interfere with things. Let's see. And here you would say draw. I would say draw the individual constitutive equations. Okay. And then so we're gonna go here on the right hand side on this. We will do this other one. This is the source of flow in here. And so let's put the numbers in here. This is E sub 8. This one is F sub 8. This is E sub 7. And this is F7. This one is E sub 4 and F sub 4. This is E sub 3 and F sub 3. And this is E sub 1 and F sub 1. And the other two are going to be, for the I element, you have, this is going to be E sub 2. Here's E sub 2 and F sub 2. Yeah. We are still are in need of the bottom ones. These are F5 and F6. No, E5 and E6. So we go over here and we say, okay, this is E sub 5 and F sub 5. And this would be E sub 6 and F sub 6. And so how do we make the connections now? What we need to do is do the connections, do the individual equations, individual constitutive relations. Take a look at what the I element is doing, and then we're going to draw the constitutive laws of this element, of that one right there. So do you see how the effort goes in and then the flow comes out? Yeah. So we are going to over here say the flow is out and the effort is in. How does this work? The first thing you do is you integrate this, and later on you multiply 1 over I and comes out as F. That's the constitutive law of this element, of this I element in there. Yeah. So in here you have the we go over here and do the other ones, the C and the R, which are on the C element. Do you realize what's going on here? On the C element, you have the the effort goes, how are we saying, the effort goes out and the flow goes in. So if this is true, the effort goes out and the flow goes in. This is like this, and this is like this. So what happens to this? You first integrate 1 over S, and then you put through 1 over C, excuse me, and then out for the R element that you have on the right hand side. And here for the R element, this one right here, see this one right here, yeah, right here you can see it, where you have the effort out and the flow in. So the flow in like this comes into here and gets multiplied by R, and out comes as E, like this. And we have finished all the elements. Now all we gotta do is do the connections. So this will take just a few moments, so that we can finish this. We could start with any one. If we start with the one over here, this one is okay. We start with the one on the right hand side. See, the one junction has all the flows are the same. So you connect them like this, see? Like this. This one was a source of effort, which the effort comes out and the flow goes in. In the case on this one is E is like this and flow is like this. I am following the bond graph model like this. And this flow is out and this effort is in. So what happens to the E over here? They will add up, see? But this is saying that E2 is E sub 3 minus E sub 1. We need to follow what the arrow says. It says E2 is E1 minus E sub 3. So E2 is E1 is in the positive and minus E sub 3 like this, because the equation is that E sub 2 is E1 minus E sub 3. That is right here on this one junction. If we do the 0 here, all the efforts are the same. So let's do that. All the efforts the same, but the flows need to add. And so we put them in here like this. The only question is, what are the signs? On that one, it says that f sub 3 minus f7 is f sub 4. So which way is this written? This f sub 4 is like this, right? And so this is f sub 3 minus f sub 7 is f sub 4, so f sub 3 is plus, and this is minus. And then I'll write it down. This is f sub 3 minus f sub 7 is equal to f sub 4. That's what this junction is doing. So finally, the last one, that is the one on the right hand side, on the left hand side, has all the flows and the efforts the same, so this one will have the connection like this, see? And that would finish the block diagram for this. Oh, no, sorry. We still have one more to go. The one on the down, all the flows are the same. So connect all the flows the same. Um, let's see, someplace in here maybe? Uh, yeah, like this. So this flow connects with this and with this. And in here we will have the summation of the efforts, see? And the only thing left for me is to determine what the signs are. And for that we need to look at the way things adding in this. See, what is this telling us? This is saying that E4 is E5 plus E6, but the way this is written is, yeah, E4 is equal to E5 plus E6, right? So if this is true, this E5 plus E6, both of them are positive, because you see the way the arrow is, this is the output of this, E5 plus E6 is E4, and that's exactly what this is telling us. This E4 is E5 plus E6. So with this, we finish the block diagram of the entire model. And we have gone from this bond graph to this block diagram.